So let's look at part 2 for the Unit 7 test. First ones we're dealing with are our varying equation, either direct, inverse, or joint variation. When we want to find the constant of variation, that's going to be our k value. When we have these, whatever varies, so if z varies, then it's going to be z equals. And how it varies is always based off of that k value. Okay, so it varies jointly as x and y. Joint variation means that you're multiplying multiple things together. So it's going to be k times x times y. So k x, y. And it tells us z is 300 when x is 400 and y is 5. So we can plug those values in, and we need to first find k, which is our constant of variation. So 300 equals k times 400 times 5. We can take a calculator. To get k alone, we would need to divide both, or we multiply 400 by 5. So that's 2,000. So we have 300 equals 2,000 k. And then divide both sides by 2,000. So 300 divided by 2,000 equals 0.15. That is what k is going to be. That's my constant of variation. When I state the equation, it's this equation only plugging in the k value. So it's z equals 0.15 x, y. Now it says find z when x is 600 and y is 15. So all we're doing is we're saying 0.15 x 600 times y of 15. And we get 1,350. Okay, so it says P is what varies. So P equals, and we're always based off of K. Jointly, again, means I'm multiplying multiple things together. So jointly as Q and R squared. So P equals K, Q, R squared. Then it tells us P is 450 when Q is 8 and R is 6. So 450 equals K, because I'm trying to figure out that constant of variation, 8, 6 squared. So we would need to do 6 squared, which is 36, times 8. So this is 450 equals 288 k. And then divide both sides by 288. So I have 450 divided by 288, and k is 1.5625. To state the equation, you're writing this only using that k value. P equals 1.5625 Q R squared. Find P when Q is 8 and R is 12. So it's 1.56258, and then 12 squared. It's going to give me 1,800. Okay, 24. The cost per student needed for the class trip varies inversely. So it tells me that C is what's going to vary. So C equals, I know I'm going to deal with K. Now it says it varies inversely, which means what the next thing I'm going to divide by that. So it's K divided by, it says the number of students, S. It then tells me that C is 8 when there are 64 students. So I need to once again find the constant of variation. So I have 8 equals K over 64. To find that, you're going to multiply both sides by 64. So 8 times 64 is 512. And that's what K is. So K equals 512. How much would it cost if 109 students go on the class trip? So it's asking me, what would C be? So C equals, my K is 512 over the number of students is 109. So all I need to do is 512 divided by 109. And it's going to be 4.697. And it says round your solution to the nearest cent, because we're talking about money. So 4.697 is going to be $4.70. So to write the equation from transformations, our transformation is y equals 1 over x minus h plus k, where h is how it moved left and right, and k is how it moved up and down. And what moves are the asymptotes. So in this first one, it's going to be y equals 1 over x. It moved right 3. My asymptote moved right 3, so it'll be x minus 3. And my horizontal asymptote moved up 2, so it's plus 2. This one, we have y equals 1 over x. It moved left 4, so it'd be x plus 4, and it moved up 3, so it'll be plus 3. I'll let you try 27 on your own. 28, we are starting at this equation. G of x equals 1 over x minus 3. That's the equation that we want to rewrite as if it had shifted right 6, shifted left 4, down 2, or up 5. As it is right now, this is shifted right 3 from our origin. So if I want this shifted right 6 more from where it is now, well, that's going to be y equals 1 over x minus 9. If I want it to shift left 4 from here, moving left 4, I have to move it to the left. That's going to be y equals 1 over x plus 1. Shifting left and right is going to change that h value down there. Moving up and down is going to change the k value. This one, there is no k value out here. So to move down 2, 1 over, the denominator will stay the same as x minus 3, but then down 2 is going to be, afterwards, minus 2. To move up 5, it's going to be a plus 5 afterwards. When you have your equations in this transformation form, your end behavior is going to be that last value. It's going to be your k value when it is in transformation form. So here it's minus 5. So both of those are going to be negative 5. Here my k value is 7. So both of these are going to be 7. So these ones now wants the x-intercept and y-intercept as ordered pairs for the following functions. Your y-intercept you get from standard form. That's what form these are in, is in standard form. Your y-intercept, you look at the last 2 bits there, okay? And a y-intercept is gonna be a point 0, and then you do that. So 1 over negative 9, so negative 1 over 9. Your x-intercept, to figure out the x-intercept, it's just what makes the numerator, so you'd factor it. This one, there's nothing that cancels out. So your x-intercept is what makes the numerator equal 0. So I have 4x plus 1 equals 0. So I would subtract 1. So I have 4x equals negative 1, and divide both sides by 4, and x equals negative 1/4. Your x-intercept, that's going to be negative 1/4, comma 0. Okay, so here, y-intercept, you look at the last ones, so that's going to be the point 0, 5 over negative 16. Your x-intercept is what makes the top equal 0. That's going to be negative 5/3, 0. So I would say 3x plus 5, I would subtract 5. And then divide both sides by 3, and x equals negative 5/3. Remember, x-intercept is number, then 0. Y-intercept is 0, and then number. Okay, these last ones on the back here, there's some stuff that we're not going to be able to do. What's big to be able to do here is your horizontal asymptote. Okay. What you need to know is where you get certain items, okay? This is wanting the vertical asymptote, the horizontal asymptote, and the domain and the range. Your vertical asymptote is, let's start with the horizontal asymptote. Your horizontal asymptote, that's gonna be your Bobo, Betsy, or Botzen, where you are comparing the exponents. These exponents, if it's bigger on bottom, that would be Bobo. If they're the same, that's Betsy. And if it's bigger on top, that's Botzen. Here, they're both 2, so it's Betsy, so we're looking at the coefficients now. So it's -2 over 1. My horizontal asymptote is going to be y equals -2 over 1 is just -2. Your vertical asymptote, you need to factor this. So I'm going to pull out a -2 from this. So I've got -2 x squared minus 3 over, bottom here factors as x plus 3, x minus 3. Nothing cancels here. We have 2 vertical asymptotes at x equals 3 and -3. Okay, so for these 3 questions, we're not actually going to do a lot of the information on here. What you need to know for your domain, it'll be everything except the values from your vertical asymptote and if you had any hole, okay? Okay, your domain does not include the vertical asymptote or the x value of your hole. Okay, so we're not going to worry about that stuff on any of these ones. We're going to look at figuring out our horizontal asymptote, though. Once again, this is look at the exponents. So both of those are the same. So now look at the coefficients. -4 divided by 2 is going to be -2. So that's y equals -2. Here, you compare the exponents. That's a 1, that's a 2, so it's bigger on bottom. If it's bigger on bottom, your horizontal asymptote is y equals 0. For 34, this is in the transformation equation style. So my vertical asymptote is my h value. So that's x minus 4, so it shifted to the right 4. So my vertical asymptote is x equals 4. My horizontal asymptote is how it shifted up and down. So that's k plus 7. So that's going to be y equals 7. So if we sketch this, put that horizontal asymptote at 7, this vertical asymptote at 4, and it follows, it's going to be in 1 and 3, so it follows along the asymptote until it gets to the other asymptote and it goes down it. Your domain does not include that vertical asymptote. So it's going to be -infinity to 4 and 4 to infinity. In set notation, that is x such that I'm just saying what it isn't. So x such that x doesn't equal 4. For my range, I'm not going to include my horizontal asymptote. So that's going to be negative infinity to 7, 7 to infinity, and also for set notation, it's just what it does not include. Range, I'm talking about y, so now it's y such that y does not equal 7. And my end behavior is my horizontal asymptote. (35) to figure out all of this information, we need to know where to look. This is in standard form. Standard form will tell us my horizontal asymptote by looking at that first term. So I have squared and squared. So bottom equals top with the exponents. So I look at the coefficients. That's a 1 over 1. 1 divided by 1 is 1. So my horizontal asymptote is y equals 1. My y-intercept down here, I look at the last values. Negative 16 divided by negative 12. Sorry, not negative 12, just normal 12. Okay, negative 16 divided by 12. You can simplify that. Both those are divisible by 4. So that'd be negative 4/3, and the y-intercept. So it's going to be 0, negative 4/3. To figure out any whole, you need to factor this. So the top factors as x plus 4, x minus 4, over the bottom multiplies to 12 and adds to negative 7. It's going to be x minus 4 and x minus 3. A whole is what cancels out. Both of them have an x minus 4, so that's what's going to cancel out. And if x minus 4 equaled 0, then x would be 4. So the x value, my whole, is going to be 4. To figure out the y-coordinate of my whole, what I had left over, x plus 4 over x minus 3, I plug 4 into that. 4 plus 4 is 8. 4 minus 3 is 1. So 8 divided by 1 is 8. A vertical asymptote is what makes your denominator 0. So what makes x minus 3 0? What value for x? Well, that would happen if x equaled 3. And an x-intercept is what would make the top equal 0. So x plus 4 equals 0 when x is negative 4. So if we're going to sketch this, we would sketch our horizontal asymptote. At y equals 1. Sketch our vertical asymptote at x equals 3. Include the points that we know. We know 4, 8.